Hello and welcome back to this three-part video sequence. In the first part we talked about parabolas, general forms of parabolas, and we looked at a few different equations for those. In this one we are looking at ellipses. So the general form of an ellipse, if you remember it or not, looks something like this. X squared over a squared plus y squared over c squared equal to 1. Why did I use c? I don't know. I'm going to use b. Why did I skip over b? It looks something like this. And again, so here a and b are just real numbers. They could be positive or negative. As you see, they're squared, so it's not really going to matter whether a and b are positive or negative. In general, we keep them positive because as you will see, a and b will correspond to lengths of certain axes of the ellipse. So let's just investigate this form with some drawings. So again, I'd like to just look at that equation and be able to come up with a reasonable graph for it. X squared over a squared plus y squared over b squared equal to 1. Now, how can I get a handle on this? Well, just like I got a handle on parabolas. I'm going to just set y and x to various things and see what comes out of the other variable. So maybe I'll start with setting x, let's say, equal to 0. Let's set x equal to 0. That gives us the equation y squared over b squared is equal to 1. From that, I can recover that y squared is equal to b squared. Take square roots on both sides. Be careful here. When you take a square root of a square, that isn't a perfect inverse because y could be either positive or negative, same with b. So when I take square roots here, what I actually get is absolute value of y equal to absolute value of b. So that is y is equal to, and again, we're going to assume b is positive as well as a is positive. So we're going to assume this is actually just b. And we'll stick to this convention. So absolute value of y is equal to b. What that tells me is that y is equal to either plus or minus b. So when x is 0, again, that corresponds to the y-axis, right? X is 0 at every point on the y-axis. Y is either plus or minus b. So let me draw in positive b, and on the same side, or on the other side, negative b. All right, so that's interesting. What if I set y equal to 0? Well, something very similar is going to happen. This time we're going to end up with absolute value of x is equal to a, which then tells me x is equal to plus or minus a. So let's see, maybe a is, I don't know, maybe a little bit smaller than b. Maybe a is here. And then the rest of this, if I can recognize, if I'm sort of told or I just remember that this is the form of an ellipse, then I can, again, kind of connect the dots with a curve. If I know this looks like an ellipse, now I can recover the rest of it. It's this circular oval type looking object. Again, my drawing isn't great. It's a little hard to draw on these pads, but we get what we should recognize as an ellipse or an oval type object. So maybe it doesn't seem like a lot that we're gaining here, but the important points are if I just give you an equation like this one in some form with a particular a and b, there's always this thing that at least I do is how do I remember which, here we have this axis and here we have this axis. This one has length b, this one has length a. This is the major axis and the semi-major axis. How do I remember, does a go with the major axis or the semi-major axis? Does b go with which one? How do I remember how this thing is oriented? And how I do that is exactly what I've done here. This tells us, these two pieces of information help us determine the orientation of the ellipse. And what I mean by that is exactly what I was talking about, like what are the lengths of these axes? Do they go on the x-axis or the y-axis? You notice the x is associated with the a here in this fraction, and so the a goes on the x-axis. You might remember it like that, but I always sort of go back to this technique. And I'm showing you this technique here because we're going to use a similar technique but in 3 dimensions. But when we set variables, since we have 3 variables in 3 dimensions, when we set one of those variables to a particular number, what we're going to get out is a curve rather than a point like we got here. Here we got 2 points out. Here we got 2 points out for each of those. In 3 dimensions, we're going to get curves out, and that's going to help us better understand the 3-dimensional object. I think that's all I want to talk about with ellipses. Of course, if B is bigger than A, we get something like this. If A is bigger than B, it'll stretch it out along the x-axis, and the y-axis will be a little bit shorter. But this is generally a good form for the ellipse. We want to be able to recognize a form like this one. Actually, maybe before I end this video, I want to do one more thing, maybe with some extra variables here. So what if I had an equation instead like, I'm going to throw one out there. How about z squared plus y squared over 9 equal to 1? Something like this. So now I have these 2 different variables. Rather than working in the xy plane, I'm working in the yz plane. So I'm going to orient them like this, just because I could have done z and y here. That's fine too. But I'm going to orient it like that. And again, I can play this game where I set z equal to 0. So if z is equal to 0, that's the y-axis now. And I should get y equal plus or minus 3. So y equal plus or minus 3. And I can mark that off. Maybe I go 1, 2, 3, 1, 2, 3. And then, so I know that my curve intersects plus or minus 3 on the y-axis. If I set y equal to 0, I'll get z equal plus or minus 1. So maybe this is 1 and minus 1. And I know the curve intersects that as well. And so my ellipse looks something like this. So again, it doesn't matter. We don't have to be y equal. We don't have to be dealing with y's and x's. We could be working with other variables. Again, the key is to draw our axes in a way that is familiar to us, that reminds us of the previous simpler situation that we're more comfortable with. There is another form of ellipses that we may encounter, so maybe I'll do one of those as well. So what if we had something like, you might see an equation that looks something like, how about I do 4x squared plus y squared is equal to, let's say 4. Something like this. So this is also an expression for an ellipse. One way we can recognize that is we're dealing with positive x squared and y squared, and then that's equal to something positive over here. It's one way to recognize an ellipse as well. And I want to get this into the sort of standard form that I showed you before. So what I'm going to do is I'm going to focus on this. In the standard form, this is a 1, and so I'm going to divide everything by 4. And when I do that, I get x squared plus y squared over 4 equal to 1. And now if this is my y-axis and this is my x-axis, along my x-axis I'm going to have plus or minus 1, right? If y is equal to 0, I get plus or minus 1. So maybe that's here and here will be my plus or minus 1 on the x-axis. And my y will go plus or minus 2. So maybe there's plus 2, minus 2. Without giving too much details. And then my ellipse will look something like this. So we might see forms that look like this, that have the form something like ax squared plus by squared equal to some value c over here. The idea is to divide everything through by c and then see it in the previous form, something like that. Okay. So I think that's it for this video. Again, we want to be able to recognize an ellipse that has form like this, something like this, as well as something like this, or something in general that looks like this, and how to get between the two. Okay, that's it for this video. In the next video, we will talk about hyperbolas.